There he goes. I was gonna say when there's a bit of a break.
Okay, let me see if I can record now. Oh, now it's recording automatically.
So Dr. Raja, if you look at the participants, we actually have more students joining us.
Oh, wonderful. Let me.
Sophia is there, and Lance is there, and Ariel. So
Wonderful, wonderful.
hopefully will be joining us shortly. But
I see Lance, I see Ariel, I see Sophia. Who was the fourth?
Augustine, he's still working on it.
Okay, okay. And they're all in 6th grade.
Yes, they are. My intrepid
amazing.
6th graders.
Intrepid indeed. Lawrence, I don't think we heard from you. If you wouldn't mind taking a moment to introduce yourself, please feel free to do that.
Hello there.
Hi.
From Honolulu.
Wonderful, wonderful.
Amateur interest.
Okay.
From,
how did you find out about us? Was it through Ohana Kilahoku?
Yeah.
Fantastic, fantastic.
Dr. Larry.
Who said that?
Julie did.
Oh yeah, hi.
Hello, welcome.
Aloha.
I so missed the word drafters.
Oh, a lot of people do, but it served its purpose, and it's time to move on.
Mm-hmm.
But yeah, we had a lot of astronomers come to our sessions.
What are these sessions again, Lawrence?
I have a 3-story home on the backside of Diamond Head. And the top floor was a theater loft that we could seat about 100 people. It had a stage and lighting and sound system. And so we had jazz every Sunday and other things happening on Fridays and Saturday evenings.
Mm-hmm.
So it was for about 24 years, we ran this every single weekend.
Wow. Oh.
Yeah. So one of our favorite astronomers was Shapudi. Played the jazz guitar. He's a cosmologist.
Isfan.
Yeah, Isfan, yeah.
He's from Hungary.
He is indeed, yes, a Magyar.
Yeah.
But it was a good gathering place and something that we need, but unfortunately those 2 upper floors are now all rented out. Yeah. But I've always been fascinated with astronomy since I was a little kid, and my dad helped me build my first 3-inch refractor telescope. I just couldn't get enough of watching things in the skies, and I grew up in Prague, so I would go to the Prague Observatory a lot and badger the people there.
Such a beautiful city. Oh, it's so beautiful. It has to be the most beautiful city in Europe, which is saying a lot. There's so many
gorgeous astronomical clock.
Yeah, that's the GuhaThakurta.
That too, that is very special.
And Tycho Brahe is buried in the church in the Staromias too.
Yes, he is indeed. Yep. Yeah, some great science was done over there.
And Kafka and Einstein.
Yep, that's Kafka. Yep.
All Prague was a happening place before Paris became a happening place.
Oh yeah. So Dr. Raja, is the 30 meter going to be built ever?
You know, I'm so removed from anything to do with the 30 meter in terms of the people who, years ago, I served on a committee that was the Science Advisory Council for the TMT, but I don't know. Short answer is I really don't know what the situation is. It's a highly charged topic.
Yes, too charged. It's a small minority that's leading the charge. Unfortunately, most people are ambivalent and there's a few, including myself, that are raring for it to go, and
Mhm.
I don't know where it's going to go.
Yeah, that describes my own situation very well. I mean, there's in that just my crystal ball is cloudy in terms of where it's going to go.
Mhm.
I mean that in a figurative sense. I don't have a crystal ball. But,
Yes,
you
that's
know,
scientific talk, right?
scientific talk. But it is, as you know, I mean, maybe you don't, but I'm based in California and been working with the Keck telescopes and other Maunakea telescopes for close to 30 years. Before that, I was in India, and even though figuratively it might have been as close to Hawaii, in other ways it was very far removed, culturally very far removed. And you know, there are different scars of colonialism in India than there are in Hawaii.
Yeah.
Different enough that I feel it would be irresponsible for me to take a stance one way or the other, because the issues at hand are more than the telescope. It's about land, culture, way more than about a telescope. It's really,
Oh, yeah.
and it is something that I feel would be irresponsible for me to take a stance one way or the other, given that I'm not informed, not impacted by the issues at hand.
Well, I feel that if we still had the royalty in charge here, you know, the Kamehamehas, they would be very much in favor of something like this. Yeah.
I see. But Anand and I and one of our colleagues, Sierra, you know, we run a different program, not the Shadow the Scientist program. We run, although we all run the Shadow the Scientist program as well. We help with it while we're getting staff in place for it. We run another program that is really concentrated in the summer, the science internship program that Yale was part of. Aprajita was a mentor for that. It's in that context, in the context of the science internship program, Shadow the Scientist and CREST, we had gone to a conference in Palm Springs a few weekends ago, which was the American Indian Science and Engineering Society conference. And we met, we actually made a Hawaiian connection there as someone from Weisz, Oahu. And he and several others we spoke to, the stories were very powerful and not surprising. It was not surprising if you had, you know, I've at least over the years tried to learn about some of these histories we're talking about, impact of contact and colonialism. It was very, very powerful, our experience there. You know, life-changing is a term that's used flippantly sometimes, but I really felt that it completely reset my perspective in ways that I hadn't expected. And I don't think that's the only time it's going to happen. I think we only saw the tip of the iceberg, and visiting, talking, getting to know people whose journeys are very different from our own is going to be an important aspect of this, you know, of this journey. Yeah, so I bring this up because this is, of course, what the TMT protests are about. It's, you know, not at all about the telescope. The telescope's a symbol.
Yeah.
Iolani Palace did have electric lighting before the White House did. So I guess that goes to show that the early adapters that the kings of Hawaii actually were, because Kalakaua was King Kalakaua when he updated the Iolani Palace. So who knows, if the monarchy was still there, maybe they would be able to make the 30 meter telescope succeed.
I may go back to astronomy. What piqued my interest for this particular session was the claim that the spectrographic analysis would help you determine dark matter. And I'm wondering, okay, how do you do that? Because as far as I know, dark matter is only perceivable via its gravitational effect.
It is, and that's exactly right. Just one moment, I'm going to share a password with.
Oh, Dr. Rocha, please disregard.
Oh, okay. Okay, that worked out. All right. Yeah. So what happens is dark matter and ordinary matter to both exert gravity. Now, we think in these galaxies we're looking at, there's already evidence that there's way more dark matter than ordinary matter. This is already true for the Milky Way and Andromeda, even more extreme for small galaxies. There's a general trend that the smaller the galaxy, smaller in mass, smaller in size, the more significant a fraction of dark matter it contains. We're already in the Milky Way and Andromeda. What happens is the stars are moving way more rapidly than they would have had there only been ordinary matter, had there only been matter in the form of stars, gas, and dust. This was a discovery made by Vera Rubin for the Andromeda galaxy. If you count up all the light in Andromeda, and you know that light is coming from stars, you know the mass of a typical star, what you would conclude that Andromeda should be spinning at about 80 kilometers per second. And what's instead seen is it's rotating at 250. So it's not a subtle effect. It's a dramatic effect, factor of 3 in speed. In mass, mass goes like velocity squared, so a factor 9 or 10 in mass. There's factor 10 more dark matter than ordinary matter in galaxies. And these galaxies that Alessandro is studying tonight are even more extreme. The connection between taking spectra and dark matter, the connection is we can measure how fast each star is moving within this galaxy, how fast it's rattling around. If it's rattling around very rapidly, it has a lot of dark matter to hold, to support this rattling, because otherwise the galaxy would just, if it had too little, if it had much less matter, anything that was rattling that fast would have escaped the galaxy, and what you're left with would be only those things whose kinetic energy is not high enough for it to escape the gravitational potential well of the galaxy. So basically what we're measuring is the kinetic energy, and that has to be less than or comparable to the potential energy of the galaxy for it to be in equilibrium. So we're measuring the kinetic energy, inferring the potential energy. The potential energy is, of course, produced by gravity, so that lets us infer the amount of dark matter. So it's a two-step and indirect process.
Yeah, I had made the assumption that the spectrographic analysis was for the chemical makeup rather than velocity. So that makes sense. Or momentum.
It'll be both. I mean, Alessandro's taking very long exposure, so these are faint stars, so you can measure both the velocity of each star and the chemical composition. Both of those things. So
how long are the exposures?
Alessandro can tell us. It's hours, tens of hours. I think not all of it is tonight. We observed it in September, several nights. Alessandro, what's the total exposure time you're aiming for?
We were aiming for 18 hours.
18, okay.
But we have been a bit unlucky with the weather. So in this particular galaxy, we'll probably get closer to 9 or 10. For the other galaxy we'll be looking, so far we managed to get 15 hours. And that got us more or less where we wanted to be.
The clouds are that high over Maunakea?
Tonight they're behaving.
Okay.
Most of the clouds tend to be below the summit, which is great, but sometimes you get high altitude clouds, which
Yeah.
they're not very opaque, but they can still be an annoyance.
And they're constantly changing, right? When they're clouds, it's constantly changing. That's also annoying. So last night I was on Shadow the Scientist with another group, and we were looking at some of the stars at Yale, studying these bright 12 magnitude stars. We would take a series of 5-minute exposures, and from one to the next, it would go much fainter or get much brighter. You could see the clouds were going in and out.
Mhm. Yeah.
The very streaky clouds.
Yeah.
So you guys need to hook up with James Webb then, yeah?
We are in a general sense, the astronomy community is certainly gearing up to, some people are already using it. I'm part of a team that's using it in cycle 1. That is the first full regular cycle of observing. Right now they're doing early release science, early release observations. They're sort of testing out the capabilities of the telescope, testing out some of the pipelines, software pipelines that will produce the data.
Yeah, I myself, I'm working a little bit too much right now with James Webb. Because
Cool.
we're doing some of the core work for the early release science, as Raju was mentioning.
That's such an amazing machine up there. It's just
It's a great machine, but it's very new. So we're still learning how to use it in the best way. We are learning exactly all the tips and tricks.
Yeah.
And so everything is it's very much work in progress. Everything is changing day by day in terms of the way we are using the data.
What ERS work are you doing, Alessandro?
We are doing the resolved population, ERS.
Okay.
So we are looking at 3 targets in the local group, very different from each other, but meant to test the range of capabilities. So we're looking at a globular cluster, which is M92.
Oh, wow.
We're looking at the star-forming galaxy, which is a WLM.
Oh, yeah.
And we're looking at an ultra-faint dwarf, which is called Draco 2.
And who's the PI of the ERS?
Dan Weisz.
Dan is, okay. I have to show you a picture of WLM that came across social media. This is
that the web picture?
The web picture that was being projected on a planetarium, I think the Morrison Planetarium. And there were these people who were watching this, and their comment was, we felt like we were inside the galaxy.
Oh, that's amazing.
I have to show you this thing. It's WLM, it's JWST image of WLM projected onto the screen. Maybe it's the Adler Planetarium in Chicago is where this came from.
That must be our data.
Must be your data, that's what I mean, yeah.
Yeah, it is.
The
one I love is the M92 because I think globular clusters are aesthetically very pretty because they're so dense.
Oh, they're so dense. So when I was a postdoc, Alessandro, exactly at the stage of your career, the stage of the career that you're in now, I worked with John Bacall on Hubble images of globular clusters. I was super exciting. It was the aberrated Hubble telescope originally, but it was just a spectacular site. Let me see if I can find the, oh yeah, I've just found it. Give me 1 second and I'll.
I have a very love and hate relationship with globular clusters because I think they're beautiful objects and they're very fascinating, but they still have a few mysteries that we haven't been able to resolve, and we've been scratching our heads for like 20 years or more. And in particularly, I've been working a little bit with that, and has been a little bit frustrating because they don't reveal their secrets very easily. So we've been tackling this couple of problems for a while now, but we still have a lot of work to actually understand what's going on there.
Just give me 1 more second and I'll bring this up. I'm going to share my screen. Can you see the image?
Yes.
Beautiful.
And, you know, I can see how these people felt completely immersed in this image of a galaxy. And if you look closely at this image, you'll see that there's a much higher density of stars in the center than in the, say, upper left or upper right
Yeah,
corners.
that is our data, I think.
That's your data. That's your
I think
data.
so, yeah.
And you can see a lower density of stars in the lower left, although there's something obscuring the image. But even then, you can see there's a lower density. This density of very small stars, very faint stars, this is looking down the main sequence of WLM.
Dr. Raja, what does WLM stand for?
I don't remember, but it's the name of a galaxy. Do you remember, Alessandro, what it's named after?
Wolf-Lunde Melotte. And
Is it three people who discovered it?
Covers.
Ah, okay. 3 names?
I think so, yeah.
Okay. I have a lot of images from Webb, including this one. This one.
Oh, yeah. They just released the new view of the pillars of creation.
Oh,
with
Eagle Nebula.
Yeah, but
M16.
with mid-infrared, so you can
that would
see
be
the
incredible.
dust. Yeah, that is very, very nice.
You can probably just see right through it. Yeah. No, this was what you're seeing is just slides from a presentation I have. This is also Stefan's quintet. Oh, I have to show you a particular. So this is the max cluster. These are redshifts, etc. But then look at this image. Vincent meets James Webb. Thanks, Aprajita. Is that the Webb status? Or just latest images?
That's the MIRI image for the Eagle Nebula.
Oh, wow. Let me go there. Let me bring that up. Thank you for sharing that. Let me bring that up. Okay, how do I bring that up? Go to the chat. Yeah, Twitter is a great resource for this. Oh, look at that. Wow, in the mid-infrared, these pillars have a lean and hungry look.
And I'm sure that they tinkered with the color scale to be more in theme with Halloween.
Oh, yeah, they really look ghostly. It's very good. You know, when the Pillars of Creation image first came out from Hubble, it made the cover of the San Jose Mercury News here. It was so strange in a local newspaper to see front page, image, Hubble image. This was arguably the most spectacular image Hubble has ever taken. Quite something.
I guess along with the deep field.
Yeah, there was something so visceral about this. Okay, wow. Thanks, Aprajita. That's good. Okay, I want to look at this image that this star, the stellar spectrum that collected.
Oh, I found the image of M92.
You did?
Yes.
Put it, if you put it in the chat, I can.
Oh,
display
it's a local file on my computer.
Oh, okay. You want to share your screen?
I could share my screen and show you very briefly. It's a little bit strange because the way the instrument is made, it has a gap in the middle.
Oh.
And so they pointed it at M92, and so the center of the cluster is not imaged. That was done on purpose. And so if I share my screen.
Oh, wow.
So you see that the dark band is where the center of the cluster is supposed to be. But you can basically see, you can still see the outskirts, and you see this beautiful gradient of density. And the wonderful thing is, if you zoom right through it, you will see there is a lot of galaxies just on the background of it, or very remote sources. So we took a bunch, we took this exposure just to look at the stars in the globular cluster, and here it is, a high redshift galaxy, for example. So we are basically now ultimating the analysis of this data. So we will come up with public catalogs very, very soon. I think it's going to be probably within a few weeks or a month. Okay, sorry. Now you can back to the spectra now, if you want. Just wanted to share this. Oh, you're muted, Raja.
Yeah, I'll share my spectra. Just
wanted to share because I think it's the best image we've taken is the one of M92.
Yeah, and thank you for showing us before the public release. Thank you for showing us before the public release.
Yeah, sure.
Let's see if we can see the calcium triplet in this star.
Hey, Alessandro.
Hey, Michael.
I think I'm going to go on call at this point.
I think it's a great idea.
Just if you see.
Michael, thank you.
Yeah, sounds good. We're gonna be here doing very boring exposures for like 4 or 5 more hours. So I don't think there's gonna be anything exciting happening. But
Okay.
I'll give you a shout out in case anything important happens.
And then if you want, just check that one FCS window for the reference. We'll check that every couple hours or something.
Yeah, that's what we'll do. Okay, thanks. Have a good night.
Yeah, you too.
Bye, Michael. I'm just going to play with these cuts a little bit.
That was our supporting astronomers reporting that everything is nominal and signing off for now. Are you controlling, Raja?
I am right now. Should I go back to view only?
So in 60 seconds, I will need to do an alignment check.
Okay, what I'll do is I'll stop using my cursor now. So it's all yours.
And then we'll take 3 or 4 minutes, and then it's back yours for another.
So I will just share my alignment check screen, and then it's all yours. Now let's see. This screen
is the control.
Sorry. Oh, you know what? I don't have control there. Just a moment. I'm just going to go to this screen, and now it's all yours.
Okay.
Raja, what are we observing right now?
We are observing a dwarf galaxy called Andromeda 22 that's orbiting Andromeda. This is Alessandro and Dan Weisz and others are going to measure chemical abundances and velocity dispersions of stars. So this is a mini galaxy, small galaxy that's orbiting Andromeda.
It's one of the smallest that we know around Andromeda. And so the idea is we have beautiful Hubble Space Telescope data of this galaxy. And so that is great, for example, to determine the age of the stars. But it's difficult to know the age with precision if you don't know also the chemical composition. And the data we have are not good for that. And that's why we're taking the spectra to complement the data we have already. So with the chemical composition in hand, we'll be much more certain about the ages that we're measuring. And so we have an entire picture of how the galaxy formed.
Yeah, basically there's an age metallicity degeneracy. If you reduce the age of a star, or if you go to an older versus younger star, the younger stars look bluer. But if you go to metal rich versus metal poor stars are bluer. So these two effects can confuse each other. So if you can, with a spectrum, determine the chemical composition, you're in a much better place to determine the age. From a color magnitude diagram.
Makes sense. Do you want to continue screen sharing?
We are, but am I not? Sorry. The screen share, and I'm going to take us to where this fine alignment is happening. Oh, it failed again.
It failed again?
Same thing though, action.
Yeah.
DCD readout complete.
Yep, that should do it. Last image. That looks great. Actually, the seeing is improved.
Yeah, the thing is about 0.85. It's about median, I suppose.
Yeah, looks good.
Yeah, it's been a little bit uncooperative at the beginning of the night, but now it's stabilizing.
Now it's, oh, the exposure started. Good. Okay. So this was just an align check then?
This is just an align check. And now we have an additional sequence of 1.5 hours.
Okay.
And then after that, we will have to play a bit more because we have to refocus the telescope. And then we will change the slit mask.
Okay.
We will basically look at the same targets, but the slit masks are made in a way that the parallactic angles are different.
Okay.
So we're tracking the effect of the atmosphere as the source moves across the sky. And we're gonna stay here until 3 a.m.
And this is, you said same targets, just different slit tilts.
The primary targets are the same.
Okay.
There are filler targets at the edge of the mask, and they should be more or less the same, I think, but it might be that some of them changed.
Got you.
It's basically just to track the effect of atmospheric dispersion, because we're using 600 line grating.
Okay.
We do care a lot about the atmosphere because we are pushing the spectra in the blue wavelength.
That makes sense. I have a busy night because I did this, Alessandro and I were on a Zoom call with this group in Pakistan, in Lahore Science Mela. Then we're doing Shadow the Scientist. And in the morning, I'm giving a virtual talk at the Ghana Planetarium in Accra. Then Anand is picking me up and we're going to campus to host a group of students on their visit to Santa Cruz. So students from the Amamutsun tribe. Anand, you're coming back after the Arboretum visit, right? So I can get a ride back with you. Oh, Anand is no longer here. That's right. Anand is no longer on the call, if I remember. All right, I want to show you a paper about deep fields. Aparajito and Richard. I'm going to put a link in the chat. So you can see my screen. I'm going to find a paper. This was a paper that we published in 1990. Hey, Flora. Meant to say thank you for all the thank you notes. Calais Talk, one of the parents from your school came over, who I've known for a long time, who I've been working with for many years. Calais came over with all the thank you notes, and they're lovely. Thank you so much.
Oh, thank you for coming and talking to our school. I think I know everyone enjoyed it a lot.
Oh, thank you.
It's very interesting.
It's fun for me, a lot of fun. If anyone who hasn't spoken up wants to introduce themselves, please feel free to. So let's go to that link and see what's there. This should be the full article. There's something very special about the date. It was published in April 1990, which is also the, you can see 13th April 1990, also the week in which the Hubble Space Telescope was first launched, that same year, same month. It's not giving me access. Yeah, I can't see the full article here, but it's behind a paywall. I am fading too quite badly because it's been such a long night. Oh yeah, we were looking at this spectrum. Oh, this was alignment. I'm going back into view only mode.
Okay, I'm gonna stay on target for 80 more minutes.
I guess the only reason I need to be in non-view only mode is I want to start a secure copy from one of the windows. Oh, but I don't need that.
You don't need that. You can do that from your.
I'll pull from my machine. That's right.
Yeah,
so
think your SSH should be enabled.
What should be enabled? Sorry.
So what happens is if you're running remote viewer, right?
I'm running VNC. Yeah, I should be able to.
Which means that you have automatic access through the firewall.
Exactly. I'm just looking up the directory name here in this window, so I can copy from there. Good. I'll go. Let me also, let's see. I'll need to look at the observing log from time to time just to make sure I'm copying the correct files. That's the only thing. So this one, I think I'm in view only.
Also, I'll make sure to send you a copy of the full log in a ASCII format tomorrow morning.
I can do the same when I log in. Yeah, if you remember, please do. Either ASCII or HTML would be fine. And then if you send me the names of once you send it to me, I'll know the names of the rest of the observations. Thank you. That would be super helpful, actually. Let's see, what else was I going to do? The first window, am I view only? Let's make sure. Yeah, I'm view only everywhere now, Alessandro. So we'll start copying things over. Oh, view only doesn't help me because I'm not then able to get to the observing log tab. Sorry. Now I can go into view only. Alessandro, do you know who's reducing all the data?
The M31 data?
No, yeah, exactly. And 22 data.
I think it's a bit of still not entirely clear. So I think Marla certainly has the capabilities, and
because
she's pretty quick about it.
Yeah, if she's running Pipette, then I won't. I was going to do the same, but
right. So now what happens is I think that if we want to get abundances through spectral fitting, Evan is actually the person who's most suitable for that.
Yes.
So I don't know if he has to if he wants to have a go from the beginning, just reducing the data from scratch or not. I'm sure that his timeline is going to be probably a little longer. But I'll have to decide that. We do have some preliminary metallicity, which is good enough at least to proceed with some other work we're doing on the star formation histories. The science grade and publication grade analysis, I think, still needs to be decided.
Got you. It looks like you use 7200 as the central wavelength.
Yep.
Okay, good. Mark. So I think please confirm, but I think the first calibrations I need are number 24, 25, 26, 27.
Number 24 is the first one, yeah.
Yeah, 24 to 27. What is 28? Oh, 28 as well. You've got 4 flats, right?
So what happens is I got, those are 5, right? Oh no, those are 6. So what happens is I got, some flats with the right exposure time for your targets, but I'm observing some targets for Marla with the largest slit.
Okay, widest slit.
Sorry?
With the widest slit?
With the widest slit, yeah, sorry. And so I took some other calibrations with slightly shorter exposure times.
Gotcha.
But I am not sure. Sort of 600. What's happening here?
But 24 to 28 looks like I should copy over.
Yeah, so 24 to 28 is the calibration files for the narrow slit, which is what your data have. But you will see that there is where is it? Oh, here we go. The 39 to 45, those have shorter exposure times. I mean, they would work probably if you want to combine them, they would work all the same, but they're taken not to saturate the wider slit.
I see. I probably don't need them because you've got
You
enough.
don't need them. I mean, they certainly don't hurt. Don't
No.
hurt, but you certainly don't need them.
So 39 through 45, you said.
Yeah.
And there I see you took 1, 2, 3, 4, 5, 6 flats. And whereas for the other exposures, there were 4 flats. Okay, so I see what you mean.
And then there are the calibration files for the 1200G, and for those you will only need the one with the OG55 filter, because the one with the GG400 are another setup.
That's another setup. Okay, got it. Yeah, Piper is smart enough to not to group things by, it has to be the same mass, the same grating tilt, same grating tilt, same filter. Okay, so I will start some copying then. I hope this is not bothering you, my moving the cursor around.
No, not really. I am a passive observer at this point.
Okay.
Yeah, I took 2 exposures of your star because the first one, I think this, I mean, the guider was still saturating, so I think the sky was
no
pretty
problem.
bright.
Yeah, no problem. I think it'll be helpful to have to. Thank you.
Yeah. I know. I'm just comparing to other spectra we've been taken so far. You can clearly see the sky is dominating, but I took another one after, which should be better.
Gotcha.
And I think that we hadn't focused the telescope at that point, but I don't think it really makes a difference.
I don't think it makes a difference. Sorry. Let's see, what is tonight is October 29th UT.
Yeah. It just so happens to be my birthday.
Oh, really?
Yeah, it just became my birthday.
Happy birthday.
Yeah, thank you. It's actually nice to observe. Thanks, guys.
Hey Raja, I
Yes.
downloaded the article that you shared about the HST
Oh, good.
defects.
Okay.
Do you want me to send it to you over email?
I have a copy somewhere, but thank you.
Could I get the article?
Yeah, sure. I'll send it to you both.
Thank you.
Raja, do you want to send you a copy?
Yeah, sure. CC me on it. It's in there somewhere, but it'll be nice to have it there.
Yeah, can you message me your email? Thanks.
Dr. Raja, we're going to have to say goodnight now.
Okay, take care.
Always.
Thank you for joining. Really appreciate it.
So we have students. Good night to all.
Good night. Good night.
Bye.
So Alessandro, I'm not being able to copy anything. Don't know what's going on.
Excuse me?
I'm not being able to copy anything.
You're not able to copy. What's happening?
It's not doing anything. It's just sitting there, not doing anything. I'm issuing this command. I don't know if you can see.
This sounds like you're not getting through the firewall.
Yeah, but it's not complaining about firewall. I'll show you. It just sits there doing nothing.
No, but usually that's the sign. Whenever that happens, is because I'm not in the through the firewall. But
I'm running VNC. I'm running VNC right now.
You're running VNC. That is true. Can you show me again the command?
It's on the screen right there, small.
Okay.
SCP.
Yeah.
So you're DEIMOS 4, right?
We're DEIMOS 4 tonight. Yes.
DEIMOS 4 at polo.keck.hawaii.edu.
Yeah.
/s/s data 1004 DEIMOS 4 22 October 29 D1029 underscore.
Are you sure that the square bracket formalism works with SCP?
Yeah, let me try that. Let me try it without.
Because I tried the wildcard, the star.
Yeah, when you put it in quotes, it's supposed to work. That's why I put the double
That is
quotes
true.
in.
That is true.
But let me try it with 24 like that. S data 1004 DEIMOS 4 22 October 29. Let's try this.
Yeah, that is not the issue apparently.
Yeah, it should say, do you wish to connect, etc. I don't know why.
Let me try and do it from my laptop.
Okay.
Could you pass?
Stop screen share?
No, could you paste the command in the chat just because
Of course.
That will save me just a couple of minutes of typing. Well, less than that, but anyway.
I went into whichever directory I wanted this downloaded.
Thank you.
There's a period at the end, right? Into data.
There is a period at the end, yeah. Okay, let me see. Where am I? Am I still running the notebook viewers? I am not. Okay. I actually am. I am able to go through. Yeah, the command works for me. So there must be something.
Yeah, I'm going to kill my VNC, restart it.
Okay, and if that doesn't work, I am happy to pull the data for you and put them somewhere.
Thank you. I'm going to just try killing my VNC. There. And I'm going to restart my VNC, same directory. You're Bart Simpson again. All right, so this is back. now it's working. It was my VNC that was messed up. It's copying now, Alessandro.
Okay, great. So Raja, may I ask, how did you select the RLI for your program?
For which? Oh, these ones that we're monitoring.
Yeah.
They come from Pan-STARRS 1.
Mm-hmm.
And mostly we pick things, initially we pick fainter ones, 18th magnitude, and we found that they're no good for twilight spectroscopy, too faint. So we went to between 12th and 13th, picked things that were high confidence RLI from PS1.
Complete.
And mostly we wanted blocks in the right RA range to get them at twilight and dawn.
Okay.
Those are the criteria. And, you know, they have, when they're bright like that, they're 12 to 13, they're very good, well-measured periods. And so we can predict years after the discovery where
the phase is going to be.
The phases, exactly, in different parts of the night. So
I have a couple of questions. One is, you've been monitoring already all of those?
Yes.
Okay. Would you have any use for additional targets?
Oh, yeah, absolutely. We can monitor some more.
And the follow-up question.
Sorry, we've been monitoring a few others as well. They're just up during the spring.
DCD readout complete.
But we can monitor more in the fall.
Yeah, so the targets actually, and then the follow-on question is, it could be interesting to see if there is overlap already, because I have a sample which has been selected using the ZTF.
Okay.
And
yeah, they cover the same patch of sky.
And also they have the same magnitude. So I am wondering, for some of these targets, we do need to get spectra. I am wondering if you might happen to have spectra already for some of these targets, because they are in the same patches of sky and they are the same magnitude range.
How bright?
They are 12 to 13.
12 to
12 to 14th.
Yeah. Well, you have those are the PS1 IDs in the name of the ID. So it would be easy to cross-check. And we have a few others. I can absolutely share with you which ones we've monitored, and we want to monitor a few more.
So one thing I'll do is I suppose I'll send you the list of targets I have.
Okay.
And I mean, if you have space to fit them and you think you might want to monitor a few more, those are probably targets which have the right characteristics for you.
Okay.
And at the same time, having spectra of those would be helpful for us, because we have this HST program and we want to know the metallicity of those.
Okay.
So, you know, if we might take the same data for both radial velocity and metallicity and use them in like two different directions, that's optimizations of resources.
So these would be individual stars between 12th and 13th. These are, we can get spectra of those, and time series would be helpful for you
in terms of photometry.
No, spectroscopy.
They would be helpful just because we want to know how much the abundance is changing over the phase.
Okay. So that's so you'll get the photometry from PS1, is it?
The ground-based photometry?
Yeah.
From ZTF.
Oh, from ZTF, you said. Okay, yeah. Send it to me. Really send it to me, and we'll monitor them, because we have, do you know if they're beginning of night or end of night targets?
So as of now, the visibility window just closed.
Okay.
So they're now moving, they sit at around 17.
Okay.
So let's say 12 to 17 or 18 in radial ascension. So now the visibility window has just closed.
It just closed. Okay, next
And
year.
it will open again in April.
Gotcha.
So at the beginning of April, they will start coming again into view at the end of the night, and they will slowly migrate towards through the night.
Okay.
Okay, I'll jot it down. So I remember to send you the catalog.
Please do. Please do. That would be great. I have to look at the observing log to see what other images are needed. After 24 to 28, the next set is 30. $39.
The set of 39 is not useful because it's, those are the calibrations for the widest slit.
Okay.
So the next one that you want.
So then you think the narrow slit will have too low signal to noise?
Sorry?
The narrow slit will have too low signal to noise in that set?
Yeah, certainly
Probably.
we'll have low counts. And,
okay.
And but you should have enough calibration frames for what you need. The next is
46 to 49.
46 to 49. Yes.
To 50 actually.
Yes. Precisely. 46 to 50, and those are all the calibrations, all the calibrators that you need.
46 to 50. Okay, let me go there. $46 to $50. Okay. As soon as this one's finished, I'll copy it over. And these are the 46 to 50 is the also LVM slit, but with the 1200G.
Yes, it's 1200G and the right filter.
What filter? Sorry.
It's the right filter. It's the 550.
GG455.
GG550.
550. Okay.
So tonight we are monitoring one extra thing because there has been a problem recently, and the cause of which is not entirely understood yet.
Okay.
So if you go to the tel status DNC, you will see that there is another FCS
oh yeah,
screen. So this one is a new version. And the main difference is that there are two images on top. So usually you only see the FCS images that
sure.
the last one that is taking at the moment. This one is showing that plus the reference image. Because apparently they've noticed the past few days that sometimes the FCS would report as if you were tracking. But it was actually, it would track at the wrong position. And so the two images would be offset by even several hundred pixels.
Wow.
And it would basically lock onto a secondary minimum of the cross correlation function.
Got you.
A secondary maximum. And that apparently has been happening in the past couple of days. So we're basically doing this extra check every time we are moving the telescope, and so the flexure of the instrument is changing significantly. We're just making sure that the two images are aligning.
Okay.
Because basically the FCS is not smart enough to understand that, and it will not give you any warning.
I see. I see.
What could possibly be causing these issues?
I don't think it's clear right now. So one thing that could happen, but in that case, if it's strong enough, so what happens is the flexure, the instrument flexes so much that there is another bright spot that used to be outside the field of view and enters the field of view. And so basically that is what the FCS is trying to do, is trying to match these features in the two images. And then it will basically not be able to distinguish exactly if the bright spot in the lower image is actually corresponds to the one above or to the new one that just entered the field of view. And so it will basically get confused between the two. We had that happening before, but usually the effect is strong enough that it basically just confuses this process altogether, and so it will completely stop working, so you can recognize it. But we're thinking, I mean, I guess they're thinking that it might happen that if something like that, but not quite like that, would happen, then the FCS will still think that it's doing the right thing, but it's not really. Just is creating these additional features, and then it just gets completely sidetracked. It's a very new effect, so I don't think they haven't looked into that a lot yet. So as of now, we just have this this patch to do this sanity check from time to time to make sure that the FCS is doing the right thing.
I'm going to copy, so I've copied 24 to 28. I'm going to copy 46 to 50 next.
Yes.
Okay, it's copying.
So the last part of the night will be a little bit more interesting.
A lot of hopping back and forth.
Yeah, I mean, we have I have a couple of 30 minutes exposures because I am taking red shifts for a couple of satellite galaxy candidates. And then, yeah, we basically, and that will take 1 hour, and then we spend the rest of the other hour monitoring binaries. So that will be back and forth, yeah.
See. I'm totally fading here. Long night, a long day ahead tomorrow, so I'm going to call it a night, but I'm going to finish the copying.
So just asking Annalisa, I'm not entirely sure which binaries because I am not, so the what precisely is the radial velocity because I think they're trying to constrain the orbits. I am not entirely sure about what binaries these are because it is not my main scientific project, but it is something I'm collaborating with. So they have their own sample and they ask me to take radial velocity for them.
Alessandro, the only other thing I need is what, 56, 57?
Yes, you do need 56, 57, and then tomorrow you'll need the other two that will have a random name so far. A name not yet determined.
See.
So for tonight, yeah, you only for as of now, it's only 56 and 57. Yeah. And the source is just about to transit in meridian, about 20 minutes.
Okay.
And this is, I mean, we were looking at this earlier, Raja. This source has exactly the right declination that it almost passes overhead on zenith.
Yeah, you were saying that.
And so right now, it must be beautiful to see Keck being perfectly vertical, looking overhead, which is the best configuration possible.
Mm-hmm.
This is where you want your source. So I was wondering if the source passes exactly at zenith, does the telescope need to do a sudden azimuth change?
Oh, it does. Anything that's very high up, it's rotating frantically at transit.
But so how does he manage to follow the source? Well, I guess it's still, the source is still moving slowly enough that the telescope can track it.
Yeah, I think so. I don't know the details of. Okay, it's finished copying. Oh, I have to copy number 50. So end of night is with the 1200, right?
The end of night RLR will be with the 1200. No, sorry, they will be with the 600.
Oh, I see. Beginning of night was 1200. Okay.
Beginning of night was taken with the 1200, yes.
So I've got, so far by way of frames, I've got 24, let's see, 24 to 28. Where did they go? (24 to 28). Then I've got 46 to 50. Then I've got 56, 57.
You got 56, 57 already?
I will get them next. I mean, I got, meaning so I've got 24 to 28, 24, 25, 26, 27, 28, 46, 47, 48, 49, 50, 56, 57. I'm going to copy next.
Yeah, it should be 12 files in total.
Okay. Yeah, perfect. It will be 12.
Exposure complete. DCD readout complete.
Third exposure started. Okay.
Hi, Annalise. About your question, not that I know of. I mean, of course, in order to do a radial velocity, you need to take a spectrum. Therefore, that could tell you something already about the properties of the star. Although, if you want a good velocity, you will not see a large portion of the spectrum because you need high resolution. Therefore, you might not necessarily get a special classification. You do want to use a temp, so maybe you do need to have a decent idea about the property of the star, just because the way you measure radial velocities, you match it with a template, so you want to choose the right template. And also that will help as well, because it helps estimating, knowing the temperature of the star helps estimating the how long to integrate, because it will change exactly how bright the star is at a given wavelength. So certainly having a spectral classification helps. I wouldn't say it's necessary, just because looking at the spectrum, you might already have an idea what type of star you're looking at, or you could potentially even use that very same spectrum. I mean, I guess with the right radial, with the right spectrum for the radial velocity, one could potentially try and get some other information. Provided you get a good spectrum, then you might also try and get a temperature from that very same data.
Got you. Yeah. Have to have good phases. Using somebody else's light curve, you'd have to have good phases. Okay, so I think I'm done with my copying. Got total of 12 files here. Those are the 12.
Okay. But by the way, Annalisa, if you have a color for the star, that might help already a little bit. That can tell you something about the star. And it will not be as good as a spectrum, but that can tell you already something about it. So it might give you a reasonable idea about the temperature of the star, and that is better than nothing. So if you have the fluxes, that it's already a starting point.
Just to give you a little bit more info, I'm currently having to search for an ideal candidate. And I tried to look for stars that have got very, very little research done on them, because otherwise to waste precious telescope time on a radial velocity when it's a given would not be a good thing. So some of the stars that I've got literally have got only the fluxes measured, okay, and the coordinates are there. There's a preliminary assessment of what they have, and I was able also to get some light curve data for them. But as I say, they don't have any spectroscopy done.
Right.
So when you look on Simbad, there's absolutely nothing. I mean, it's as bare as you can get. Besides, you can see the fluxes. At least you can infer more or less the as I say, the magnitudes of the star. Yeah.
But you want to get the radial velocity. So if you want to get the velocity, you need a spectrum.
Yes. No, I know. But the question is, I am going to ask for spectrums to be taken, but I wanted to know whether there should have been a spectral classification before we do the radial velocity, or not necessarily.
I don't think it's necessary. If you have the fluxes, if you have at least 2 fluxes, like a color.
Yeah.
That is already a good starting point, I think, because it can give you an idea of what type of star you're looking at.
Okay.
And so if you have a color and a magnitude, at least you can say if it's a cool star or a hot star. You might not say if it's a giant or a dwarf, but
it's a start.
it's a start, you know, and that will tell you already, it will be probably enough information to start setting up the observations. So knowing exactly how much to integrate, because you know the magnitude and you know the color, and that's already pretty good. And then once you get the spectrum, you know, you can basically do a better refinement a posteriori. So after you get the spectrum, you can use that same spectrum to start refining your models and your idea. So I think that just having 2 fluxes is enough. I mean, it depends on the fluxes, like which magnitudes are, but
these ones range between 11 and 13 G, H, and K. So yeah.
G, H, and K.
G. Sorry, G, J, H, and K.
Oh, so they are infrared.
Yeah.
So they might not be very good for determining the temperature. Which magnitude are these stars, more or less?
13 to 11.
So I am sure, for example, that Gaia has.
But the one that I do have has got visual also. It's got 13 here, and there's another one. So perhaps that's a better candidate. It's got V13.
I'm sure that
look at that one, yeah.
I'm sure that the stars are so bright that if you look into other catalogs, like I'm sure that Gaia must have some other measurements of those already.
I'll check.
Yeah, and I think you will find a lot more information, and that would be great, very helpful.
Because as I say, I'm going through somewhat in terms of what is there. But it's a tricky one. I'm looking for stars that have got very, very little information on them.
Right. I would suggest to check the Gaia catalog, because it is, as of now, is one of the most complete.
Yeah.
And so if you just have the coordinates of those stars, you can feed them into the Gaia catalog, and you will try and see if there is more information available.
Okay, we'll do that.
Yeah, sure.
Thank you so much.
Yeah, of course.
Alessandro, I'll sign off now. Please send me the observing log and I'll copy the rest of the things over then.
Absolutely. So
thank you.
If it's not tomorrow morning, it's going to be early next week.
No rush. No
But
rush.
I'll probably try and do it by the end of the night.
Okay, perfect. Thank you.
Yeah, thank you.
Thanks for taking these data.
Company.
No, and thanks for taking these data for us. It's really great. All right, you take care, and I will sign off then. And I'll stop the recording and all that.
Yeah, and we'll